How many ways can 6 people be split into 2 equal-sized groups? Pause the video and organize the information about this question. There are 6 people in the sample set. We can choose 3 people for the first group in 6 choose 3 ways. We can choose 3 people for the second group in 3 choose 3 ways. There are 6 choose 3 times 3 choose 3 equals 20 ways to form 2 groups from 6 people. Now we'll move on to part B. Show that 25 factorial plus 26 factorial equals 27 times 25 factorial. Expand 26 factorial. Stop at 25 factorial since this matches the first term. Factor out 25 factorial. One plus 26 equals 27. We have now shown that 25 factorial plus 26 factorial equals 27 times 25 factorial. Now we'll move on to part C. 5 different types of fruit and 6 different types of vegetables are available for a healthy snack tray. The snack tray is to contain 2 fruits and 3 vegetables. How many different snack trays can be made if blueberries or carrots must be served, but not both together? Pause the video and organize the information about this question. There are 11 food items subdivided into 5 fruits and 6 vegetables. First, create a snack tray including blueberries and excluding carrots. We can select blueberries in 1 choose 1 way, another fruit in 4 choose 1 ways, and 3 vegetables, excluding carrots, in 5 choose 3 ways. Restock and redraw. Next, create a snack tray excluding blueberries and including carrots. We can select 2 fruits in 4 choose 2 ways, carrots in 1 choose 1 way, and 2 other vegetables in 5 choose 2 ways. Add the 2 cases to get 100 possible snack trays. Now we'll move on to part D. In genetics, a codon is a sequence of 3 letters that specifies a particular amino acid. A fragment of a particular protein yields the amino acid sequence shown. How many unique codon arrangements could yield this amino acid sequence? Rewrite the amino acid sequence. There is 1 codon available for the first amino acid, and we require 1. This can be done in 1 choose 1 equals 1 way. Write the combinations for the other amino acids in the sequence. Condense the expression. Evaluate to get 1,152 possible codon arrangements. In method 2, we can use the fundamental counting principle. Draw 6 positions. We can't rearrange the amino acid sequence, so the positions are locked and repetitions are allowed. Multiply the number of options available for each position to get the answer, 1,152. Now we'll move on to Part E. In a tournament, each player plays every other player twice. If there are 56 games, how many people are in the tournament? Pause the video and organize the information about this question. We can represent the problem with the equation 2 times n choose 2 equals 56. Divide both sides by 2. Expand the left side using the combination formula. Two factorial equals 2. Cross multiply. Expand the left side. Stop at n minus 2 factorial since this matches the right side. Cancel. Expand and bring all terms to the left side. Factor. The solution is n equals -7 or 8. Reject -7. The answer is n equals 8. Now we'll move on to Part F. The discount shelf in a bookstore has a variety of books on computers, history, music, and travel. The bookstore is running a promotion where any 5 books from the discount shelf can be purchased for $20. How many ways can 5 books be purchased? Pause the video and organize the information about this question. The quantity of books on the discount shelf was not given, so we can assume there is an unlimited supply. Create a chart to form some sample book combinations. One possible selection is CHMTT. Another possible selection is HHHMM. We can arrange 5 identical checkmarks and 3 identical dividers in 56 ways. Now we'll move on to Part G. Show that n choose R plus n choose R plus 1 equals n plus 1 choose R plus 1. Rewrite the equation. Expand each combination on the left side using the combination formula. Simplify the denominator in the second term. Factor out n factorial. Now get n minus r minus 1 factorial in both denominators by expanding n minus r factorial in the left term. Factor out n minus r minus 1 factorial. Now get r factorial in both denominators by expanding r plus 1 factorial in the right term. Factor out r factorial. Get a common denominator in the brackets. Add the fractions. Simplify. Multiply the fractions. Arrange the factors so larger factors are on the left. The factors in each rectangle can be condensed. By the combination formula, we can write the fraction as n plus 1 choose r plus 1. Now we'll move on to part H. How many pathways are there from point A to point C, passing through point B? Each step of the pathway must be getting closer to point C. In this 3D pathway, we can move from point A to point C using arrangements of north, east, and up. Example pathways for A to B include ENU and UEN. So the number of pathways from A to B is the same as the number of ways E, N, and U can be arranged. We can arrange 3 different letters in 3 factorial equals 6 ways. Since there are 2 cubes, we are moving from A to C. The second cube will also have 3 factorial equals 6 pathways. Multiply to get 3 factorial times 3 factorial equals 36 pathways from A to C. Note that we multiply the pathways from each cube instead of adding because the movement from A to C counts as a single case.